Dear friends, a building management control or a programmable logic control has been introduced long time into the industry to help us to control better all kind of equipment. In my case, I am a gas registered engineer. I have Hvac for about 35 years and I'm a refrigeration and air conditioning engineer as well. I'm doing a lot of Hvac and I have MVQ in electrics. Later, to get rid of a lot of frustration related to the control, I undertook Siemens Programmable Logic Control courses, Omron SCADA, Ladder Logic courses, and that helped me to understand better the control. So sometime when you service an equipment, you have to understand how that equipment works. Or if you want to write a software, you have to be Hvac too, because you understand perfectly how the Hvac works. As you'll see here on a whiteboard, I wrote a software demanding to the software engineer to put onto the PLC all the data and to write the software according to my demand. Later, I learned to do that myself. So first, I put on the paper everything about the AHU or gas boilers or full heating system, and I wrote the software myself, either on Siemens PLC, Logo PLC, Siemens BMS, Trend, and CruiseNet. Now, as you will see on the left hand side, I have inputs, in the right hand side I have outputs. What is in between? It is your concept. So it's very important to understand control. Just imagine, you will build a plant room, and what you see, they boilers. I got the boiler number 1, and I got the boiler number 2, and finally, I got the boiler number 3. So I choose to have 100% total capacity provided by 3 boilers. If one will fail, at least I have 66% of the capacity. So after I designed the boilers, my manager decided to deal with the company which integrated the boilers into an entire heating control system. So they fitted a building management control, a Compre HX in my case. Now, when we go to gas courses, we've been told that if we have a mechanical ventilation into the boiler room, we're supposed to have these fans, differential pressure switches, interlocked with the boilers. In my case, the boilers were interlocked with the building management control, but not in a safe way. So the fire alarm, the CO probe, the pump, the circulating pump, the pressurization unit, and the fans was sending the inputs to the building management control, and ultimately the building management control were sending a signal to the boiler if to run or not. So basically, the ventilation system has been interlocked with the building management control and not with the boilers directly. Or they should be both. If you interlock the BMS, the building management control, you should interlock through a group of relays each boiler, because safety takes over the control. Unfortunately, this was not the case, and one engineer played a hero and he did a huge mistake, breaking the law. A very respected engineer did not have the appropriate knowledge, and without knowing, or maybe knowing, he broke the law. As you will see, everything which is painted with green means it's healthy and works. So once everything works, the PLC will start the boilers one by one. As you see, they green. So all the boilers come on and everybody was happy. System runs perfectly until the extractor fan got faulty. Now the boilers has been turned off by the PLC, which is alright. And I told the manager I can't turn them on because I have a faulty fan. But the manager spoke to one of my colleagues, which was a respected gas engineer, and my colleague spoke to the boiler company on the phone, and he managed to manipulate the local control and the LMU to change its settings, and the boiler started running on a local controller. So the boilers ignored the fact that the PLC was asking for the boilers to be off because of the faulty extractor fan. So I have a ventilation problem. And then he was a hero because he heated up the store without ventilation in the plant room, which is practically illegal. He breached the HAC rules. So, coming back to my story, if the fan would be integrated directly with the boilers, he wouldn't be able to turn the boiler on. But because it is integrated with the PLC and the PLC used a control as a safety, then the fan differential pressure switch, which sends a signal to the PLC, did not stop the boilers if the boiler local control was bypassed. And that was bad. Thank you very much, and I'll see you next time.